Welcome back to our discussion about the graphs and applications of quadratic functions. And this is the last of the 5 videos in this series. And this video will be talking through an example about how to solve problems using minimum or maximum value of a quadratic function. So let's take a look. All right, Katniss's arrow follows the path of a parabola. The height of the arrow, f of x, can be modeled by the function f of x is equal to negative 0.005x squared plus 2x plus 5, where x is the arrow's horizontal distance in feet. Now we've got 3 questions going on. What is the maximum height and how far from its release does it occur? Whenever you've got a word problem and it is a quadratic equation, and you have something that says maximum or minimum, that is going to be talking about the vertex, specifically the y of the vertex. Okay, just like what we've done before, the max and where it's happening refers to the y and the x of the vertex. Now, the second part of this first problem is how far from its release does this occur? How far? That's a location. So where x is the arrow's horizontal distance, okay, that's going to be talking about the x value of the vertex. So of these two, you know that you can't find the y without finding the x first. So let's go ahead and find the x of the vertex by using negative b over 2a. And when we simplify that all up, we get x is 200 feet. Okay, so the highest point of the arrow happens 200 feet horizontally from where Katniss shoots it. Now the y of the vertex, that would be found by f of 200. So subbing in 200 everywhere we see x, we're going to get a y value of 205. So the maximum height is going to be 205 feet. Okay. Now the last bit of this problem is use a graphing calculator to find the horizontal distance the arrow travels before it hits the ground to the nearest foot. Okay, so let's think about this. If you were to put this into a graphing calculator, you are going to get a curve that kind of looks like this. All right, notice we have a parabolic curve. It's opening down, and that makes sense, right? Because an arrow is going to shoot up, and then it's going to come down. All right, and that also makes sense because we've got this negative out in front. We've got a reflection. Notice it does not start quite at the origin because Katniss has some height to her. She's not shooting this arrow from lying on the ground, and she's shooting it from about 5 feet up. Okay, now she's taller than that, but from where she's shooting, it's going to launch from about 5 feet from the ground. Okay, so what we're looking for is what's the horizontal distance that the arrow travels? So if you're looking at this, you're thinking about, okay, the horizontal distance is going to be this x-intercept. It's not going to be this x-intercept because that doesn't really apply here, right? So let's go ahead and think about what would this x-intercept be? Okay, and so this we can just pull directly from the graph. You can use your zero tool if you're using a TI product. This is a graph from Desmos, and I was able to just grab that from Desmos. And so this is 402, it's about 402 feet. Okay, and that makes sense. If it takes about 200 feet for it to get to the peak, it's going to be a little bit more than that to get to the ground because she started a little bit higher, right? Okay, so that does make sense. And that wraps up this video. So, you know, I'm going to infringe some copyright here and say, may the odds be ever in your favor. We'll see you next time.